Hello all, my name is Sujin George and welcome to this lecture series of surveying. In today's lecture, we'll be discussing about trigonometric leveling. This is also known as indirect leveling. Now, trigonometric leveling, it is the process of determining the differences of elevation of stations or points, stations may also called be points, from observed vertical angles and known horizontal distances. The vertical angles may be measured by an instrument which is known as the theodolite, and the horizontal distances are measured by the chain or tape. Now, in the trigonometric leveling, two cases arises. First is when the base of the object is accessible, and second is when the base of the object is not accessible, or when the instrument station is in the same vertical plane as the elevated object. So, in this we will see the first case, that is the case 1, when the base of the object is accessible. This means that when the horizontal distances could be measured quite easily. Okay, so this is a figure. In this figure, this is a level ground. This is a level ground. The instrument, this instrument is known as the theodolite. This instrument, it is known as the theodolite, and this theodolite, it measures the vertical angles. This is one tower TP. Okay, this is a tower TP, and this is one leveling staff at this benchmark. Now, we need to find the height of this tower TP, this height of the tower TP, as well as the reduced level of the top of the tower. So, here we need to find height of tower TP, height of this tower TP, and also reduced level of top of tower, means top of tower is this point P. So, we need to find both. So, let us see how this can be done. Now, here when suppose this is the line of axis of the theodolite, or you can say the line of collimation. Okay, this is the line of collimation. The theodolite can measure the vertical angles. The theodolite can measure the vertical angles. So, top measurement, that is when we sight this top point P, we will get some angle, let that angle be alpha. This angle is known as angle of elevation. Also, we can measure the foot of the tower. The foot of the tower can also be measured. Foot of the tower is at this point T. So, let this angle be called as beta, and this angle is known as the angle of depression. Horizontal distance between the tower and the theodolite station, let it be denoted by capital D. Also, this theodolite, the first reading taken on the benchmark, let this reading be H1. Let this reading be H1. So, suppose this reading is H1, obviously this reading, it should also be equal to H1. Okay, if this is H1, so this reading should also be equal to H1. Now, let this top reading be equal to H2. This reading, let it be equal to H2. And the total height of the tower, let it be capital H. Now, based on this parameters, we have to find the height of the tower TP, that is equal to H. And also we need to find the RL of top of the tower, that is this RL of point P. Now, this is when the base of the, this is case 1, when the base of the object is accessible. When the base of the object is accessible, it means that this is a level ground, and here you can easily measure this distance D. This distance D can be easily measured. So here, if we consider this triangle, suppose this triangle is A, P, and this is C. This point is C. Suppose if we consider this triangle APC, this triangle APC. So this is actually a right angle triangle. Okay, this is actually a right angle triangle. So here this tan alpha, it will be equal to opposite upon adjacent. So tan alpha, it is equal to opposite upon adjacent, that is H2 upon this distance D. This will be H2 upon D. So H2 is equal to D tan alpha. Similarly, if we consider this triangle ATC, if we consider triangle ATC, this triangle ATC, so here tan beta will be equal to H1 upon this is again D, so it will be H1 upon D. So H1 is equal to D tan beta. Okay, this H1, it is equal to D tan beta. So the total height of tower TP will be equal to H. The total height is H, that is equal to H1 plus H2, that is equal to H1 plus H2, and it is D tan alpha plus D tan beta. Okay, so we know this distance D, we know these angles alpha and beta, so we can find the total height, that is this H. Okay, so this height has been found out. Second, we need to find the RL of top of the tower. RL of top of tower, that is RL of top of tower, it is equal to RL of point P. RL of point, this point P. Now this point, RL of this point P, it will be equal to this RL of benchmark plus this height H1 plus this height H2, isn't it? So this will be equal to RL of benchmark plus this height H1 plus this height H2, H1 plus H2. But here H1 plus H2 is equal to the total height itself. H1 plus H2 is equal to the total height. So this RL of point P, it will be equal to RL of benchmark plus total height H itself. Okay, so this is the simplest case, that is when the base of the object is accessible. Okay,